We are given this function h of t equals 2.962 sine of 0.508t minus 0.107 plus 3.876. This h of t represents the predicted height in meters of the tides at the Prince Rupert, British Columbia, for one day in February. And in part A, we have to determine the maximum height of the tides. So let's understand a little bit about this general sine function. Here we have this sine function f of t equals a sine bt plus c plus t, where A is the amplitude, B is a period constant, that is 2 pi by B gives a period, and C is a horizontal phase shift, and D represents the vertical phase shift. So first, let's identify the A, B, C, and D from this sine equation. That is, this is A, and B is 0.508, C is negative 0.107, and then D is 3.876. Okay, so now we will determine the maximum height. Since we have a vertical shift of 3.876, the maximum height of the tides is given by amplitude plus the vertical shift. So amplitude is 2.962 plus the vertical shift is 3.876, and this is in meters. And so adding this, we get 6.838, and the unit of this height is meters. So the maximum height reached by the tides is 6.838 meters. Now let's answer part B question. That is, we determine the period of the sinusoidal function. We know that period is given by this formula 2 pi over b. So I write period, and this equals 2 pi over b. B here is 0.508. So I put 0.508. And so when we calculate this, we get approximately 12.37. And the unit of period is hours. Therefore, we have determined that the period of this sinusoidal function is 12.37 hours. Let's answer part C. Here we have to determine the height of the tide at 12 noon. So basically, we have to plug in t equal to 12 into this height function. Since t represents the number of hours since midnight, 12 noon basically represents t equal to 12. So let's do that. So we are going to get h of 12, and this equals 2.962 sine of 0.508, and this has to be multiplied by t, which is 12 now. We replace t by 12 minus 0.107 plus the vertical shift, that is 3.876. So let's simplify this. We get 2.962 sine of, we multiply these two quantities and then subtract 0.107, and when we do that, we get a 5.989. We then have plus this vertical shift 3.876. We can plug this expression into the calculator. That is, we find the sine of this number, multiply with 2.962, and then add 3.876. And when we do that, we get approximately 3.02. This is rounded to two decimal places. So this is the height of the tide at 12 noon. This is in meters.